People utilize their microwaves for many reasons, such as heating their food and other products. Personally, I use it to heat my milk. But have you wondered how the microwave works? Percy Spencer had tragic beginnings. His father passed away when he was born, and his mother left him away with his aunt and uncle. However, at the age of 7, his uncle passed away as well. Percy Spencer did not have a formal education in grammar school or in any other subject. However, his perseverance and persistence allowed him to develop knowledge of physics, calculus, trigonometry, and other prominent areas. In 1939, Spencer began working for a company known as Raytheon. This company was responsible for developing microwave radar transmitters in World War II. One day, in 1945, he noticed that his candy bar began to melt. With little experimentation, he found out that the magnetron was secreting microwaves, which are small radio waves, and these microwaves were melting down objects. This led him to create the first microwave, which was responsible for making popcorn. He patented the microwave in October of 1945, and in 1945 the first microwave was available. Ever since the first microwave was available, the microwave has been embedded as a common appliance in many houses. Primarily, microwaves are used for heating and reheating of food. Although we conspicuously cannot view physics at the exterior level, physics, however, occurs at the interior level in the minute form. Microwaves are a form of electromagnetic radiation. Electromagnetic waves are transverse waves that consist of electric fields and magnetic fields oscillating perpendicular to each other. Microwaves have a frequency of 2.5 gigahertz and they travel at the speed of light, which is 3 times 10 to the power of 8 meters per second. Microwaves are created by the magnetron, which is a small tool or utensil located in the interior of the microwave behind the cavity. The magnetron is a hollow form with the cathode and anode along with an electric field that is directed toward the anode and also a magnetic field that is directed perpendicular to the electric field. The equations such as B equal to FB over QV sine theta and E equals to F over Q or Kc times Q over R squared newtons per coulombs are useful ways to describe the magnetic field and also the electric field respectively. The low voltage provided by the power outlet results in an increase in temperature of the filament. This increase in temperature results in an increase in molecular motion, which eventually becomes very high that electrons are emitted out of the cathode. Due to the presence of an electric field, electrons are excited and they travel toward the anode. However, the magnetic field that accompanies the electric field curves the motion of the electrons, and so instead of the electrons going straight, they curve in a motion that generates energy. This energy is transferred to the resonant cavities. The energy transferred by the electrons pumps the natural frequency of the resonant cavities or holes in the anode. The given energy results in resonance of the resonant cavities. The resonant cavities, as a result, emit microwave radiation. The microwaves then are captured by the windpipe, which is a hollow tube that extends from the magnetron to the steerer. After the microwaves enter the windpipe, the microwaves are traveled toward the steerer, which scatters the microwaves into the cavity, or the internal of the microwave. The electric component of the microwave causes water molecules to rotate. Kinetic energy, which is energy of motion, is calculated by the formula 1/2 mv squared. So as the water molecules exchange kinetic energy, they result in more collisions as the molecules are traveling faster and faster and bumping together. According to the kinetic particle theory, as the water molecules get hotter, there are more collisions, and that is known as heat. Some of the water molecules absorb the energy provided by the microwaves. However, not all of the microwaves are absorbed by the water molecules. This explains why the microwaves are made of metal surfaces, because the metal surfaces reflect or bounce off the microwaves, thus allowing them to have a greater chance of being absorbed by the water molecule. Although the microwaves reflect off the metal surfaces, this interaction sometimes produces standing waves. The water molecules therefore do not gain enough energy. In order to reverse this effect of not heating, the microwaves are given turntables. This results in allowing the water molecules in the food to absorb the energy, therefore becoming heat. The rotation of the turntables has many types of velocities and forces and accelerations acting on it, such as angular velocity, which equals to theta over time, tangential velocity, which is equal to radius times omega, or angular velocity. We also have centripetal acceleration, which is equal to radius times omega squared, radius times angular velocity squared. And finally, we have centripetal force. The formula for centripetal force is equal to mass times centripetal acceleration. Last but not least, we have all types of laws affecting how the microwave functions, such as the law of thermodynamics. The idea that energy is not created or destroyed, it is transferred. Electrical energy from the outlet is transferred into various forms of energy that eventually heats our food. As you can see, that is how a microwave works.